Okay, so with housekeeping items done, I just want to give you guys a little bit of context on why we're doing this webinar before we hand over to Mario. First of all, it's basically not just us talking about this issue. There have been plenty of articles about EDR evasion, lots of LinkedIn posts and Reddit posts about EDR evasion. Yeah, obviously, EDRs aren't the only cybersecurity tool that are prone to evasion, but I think it's been such a big topic because for a lot of people, EDR is the cornerstone of their cybersecurity stack. But when you look at what the EDR covers in the network, it doesn't necessarily gather all the telemetry you need to get a full picture. So yeah, here we have an example just looking at how, EDRs don't necessarily look at telemetry coming from IoT devices or from OT environments, and especially cloud environments, which is basically where a lot of where the network is moving these days. So the other point that's quite important here is that when the EDR gets bypassed, it usually isn't just your EDR that gets lost. Your XDR, your extended detection response, and your MDR, your managed detection response, also relies on the EDR telemetry to gain the visibility that they need. So those services also might get bypassed at the same time. The other points I want to make here is that we've seen multiple different types of EDR evasion techniques, of which we will be looking at one today. Recently, we did a report from CISA Adversaries where we looked at 12 different ransomware groups, and each of them used a different technique to bypass EDRs. Also, there was another report that found that almost every commercial EDR solution was susceptible to one type of EDR evasion or another. So I'm excited to see our demo today. And with that, I am going to hand over to Mario Lobo. Mario, over to you.
Hey, Julian. Hi, everybody. It's a pleasure to stay here. Okay, today the idea is to show how info stealers and ransomwares are bypassing EDRs. The technique that we will use is special, is very special because it can be applied in several EDRs. The technique that we will use, obviously in terms of EDRs. I will first introduce you to some general context to understand the bypass POC or proof of concept. Well, the idea for this session is to be able to implement a bypass to EDR using AMSI, the anti-malware scam interface. It is a functionality, it's a feature that was implemented in Windows, starting in Windows 10. But to understand what AMSI really is, we first need to have a little context, a small context, of the general operation of the EDRs. Here, we can see the general architecture of an EDR. It's very general. Basically, this agent service is a small engine that processes information that comes from different collectors, different sensors. You can see here, static scanner, alarm drive, kernel mode driver. These sensors provide the EDR with information to be processed internally using static algorithms or AI algorithms, AI floats, and can determine if that information or if that behavior it took is trust or is malicious. Here we can see, for example, a static scanner, which is the most well-known anti-malware system, the most common system, where we have some files and where we have images of the processes that are running in the system. From these files and these images of the process, a hash is extracted. Okay, that hash is a kind of signature or a kind of fingerprint that determines that the file is totally unique. The EDR here take these values from the OS using this sensor for this case and makes a match with a database with the hashes of malicious files and malicious processes and determine if the process or the file can be considered malicious or not. That is the correlation system that we have seen all our lives. And that is how anti-malware or antivirus system began. In the time, other layers were added. For example, here, ETW, that actually is event tracing events, the event tracing logs, which is where absolutely all the chains to the OS, all the chains in the operating system are recorded. All the chains to Windows at the registry level, at the file level, memory level, configuration level, etc., etc. So these events are recorded in a database and passed again to the EDR here in the agent service. And that determines, according to the same thing, static algorithms, AI, whatever concept that the EDR has, if that behavior of the logs that take from the OS can be considered malicious or trust. Okay, there are more deeper sensors like here, a kernel mode driver, that basically what it does is a kind of hook and interception of the processes to know where they go. What are the DLLs that they call, the libraries that they call, what is the interaction with the kernel, take all the telemetry, pass again to the EDR, and it determines if this interaction of the processes is valid or not. It's the same thing for all the collectors. An interesting thing here with the kernel mode driver is that this sensor, every sensor or collector are provided by the operating system, but some could be also created or developed by the anti-malware vendors or anti-malware providers, EDR providers. Obviously, creating all these sensors is very complex. And you know, with great power comes a great responsibility. And do you remember what happened with CrowdStrike, for example? This specific sensor, the kernel mode driver, it was tampering and disrupt the operation of millions of systems around the world. Okay, so we can see that the operating system then brings several sensors, several collectors to provide anti-malware vendors with all the information so they can make a decision about the execution in the system. This is an overview of the EDR, and in this context, the AMSI is a collector or a sensor more, okay? But what AMSI is? AMSI, I say before, anti-malware scan interface, is a window feature that allows scripting language-based applications to integrate more deeply with antivirus or anti-malware products, with EDR products. In short, it is a collector or sensor specialized in script codes, okay? Codes that run in memory. it was included in Windows 10 to improve the security of PowerShell, or the security using scripting languages or code executes in memory. Sorry. What is the AMSI integration? AMSI is full integrate into the following Windows components: PowerShell with Windows script host, WS script and CS script, JavaScript and Visual Basic script. Also here is the browser's functionalities and Visual Basic. And also Office and macros. Why scripting languages? The easy way, you know, less developed time and overhead for the attackers. Bypass application, allow listing, because any small modification in the code generate another hash. So this match that we saw before is not possible with small changes. To me, the most important that the entire code is executed on memory. This, to me, is the most powerful feature of the scripting language. Is portable and use the system frameworks. It's present in all the devices. And why scripting languages are important to the attackers? This is the big problem. The big problem is that the most prominent ransomware gangs use at least one of these programming languages in their attack chain. And if you can see here, info stealers also use these scripting languages with high success rates. The entire cyber kill chain is covered by this technique. It is transversal to all the stages. Okay, with this small context in the next POC, the next proof of concept, we will see how using a PowerShell script, PS1 code, I can patch the AMSI buffer that actually is the space that saves the code that should transfer to the EDR to avoid the provider from taking the real code and always receive the trust response. Always receive a okay response after the code is processing. In the example, the anti-malware provider, the EDR provider, is a Windows Defender, but this technique works for several EDRs with the same concept, okay? Okay, I'm going to turn off my camera for a moment so I can set the environment for the POC. Just give me a minute, please. Okay, on this occasion, we are going to apply a patch that will change the buffer, the AMSI buffer, so all the responses say that the container is valid contain. In this scenario, we have the screen divided in two parts. On the left side, we have a PowerShell window where we are going to run the AMSI bypass test. And on the right side, we have the entire Windows security settings where we can see that all the options are enabled. For example, here we have the current threats and the virus and threat protection updates are today. So here in Manage Settings, we can see how the real-time protection is enabled. The cloud protection is also enabled, and tamper protection is enabled. Here, we just left the automatic sample submission because in case we have some issue with the test, the sample could be burned. So this part is disabled, but the rest of the security Windows Defender environment is totally right, totally enabled. First, we are going to get the host name. And here, it is a desktop 5VG4H0. Okay, this is the name of the host name. For this test, we are going to use a malware sample from 2023 called DNSCAT. This is from August for 2023. And this is a tool that allows us to perform DNS tunnels with full sessions in the victim machine, also reverse shells, exchange files, and it is written totally in PowerShell. Why PowerShell? Because it is maybe the most powerful scripting language for Windows. It is present on all devices by default. It executes and saves all the code in memory, so it is capable of leaving evidence on the machine. And it also contains multiple functions that we can use to interact directly with the operating system. So for the attackers, it is a very powerful tool. Okay, we are going to do it first in a normal way, in normal terms of the Windows Defender. What will be the system response? So here, we execute the command that the DNS creator tell us to connect to some malicious infrastructure. So we are going to copy here and also in this way. So we copy the command and execute it. If we realize it is execution using navigation, what this command does is that it goes to the internet, take this address, and what it finds, for example, in this case, this script, it saves in the memory system, and after that we can execute. So here I executed and was in the normal way, was blocked by the antivirus software or EDR software. So the probability to block this content is very high because it's a very older sample. So this is the normal way and how the Windows Defender is working. But now we are going to verify how with an AMSI patching technique, we can walk through this whole part and execute the remote control commands in the system without any problem or any alert from Windows Defender. This part, I'm going to execute the script. This is the script, invoke ASMC version 4. Here we create a PS1 script obfuscated to bypass the first static detection. We can note that we are in the same computer. here I execute it without any alerts or any avoid of execution from Windows Defender. And here we can see that actually is the same computer. After the execution, the script code is in memory, and we call that function to patch the AMSI buffer without problems. The function to do it is invoke as AMSI, and I'm going to enable the verbosity in the command just for that we can see how is the script behavior. And after that, I also enable the patch or ETW, that actually is the log system of Windows, to avoid that after the patch, some log could be created and alert some other collector of the EDR. So if we execute this part, now the patch was created, and here we can see with the verbosity function how the script works. In this part, we can see that it was running as a user LAN, totally normal user, not admin privilege. The first part, the script locate the AMSI initialize function and takes the memory address, calling the AMSI initialize function, and after that try to list and take all the providers that was registered in the system, how malware, anti-malware or antivirus providers. The idea of this patch is try to determine what of the entire list of providers, and before the AMSI buffer is with the total content of the code, patch the memory address to with other bytes. To do that, every code that is saved in this part of memory after the execution will be totally true, totally valid, and the operating system bypass any detection. So here we can see that the list of provider was shown, and after that the provider was patched. So AMSI patch detect one provider that was verified after persistence, and after this patch of the provider was executed the ETW patch. Here we also write another memory address to redirect the logs for other space in memory that the operating system not sending to the anti-malware software. So after that, we're going to do the same thing that we did before. Try to execute the DNSCAT software. Now I copy the instruction here. Copy. Okay, I'm going to execute it. Waiting for Here, PowerShell is trying to take the PS1 content and save all the content in the system memory. Okay, here we are going to execute the same command that we executed before when the alert of the Windows Defender. Here, I executed and any alert or any problem was presented by Windows Defender or Windows operating system. The real-time protection, cloud delivery protection, and tamper protection is enabled, and any alert was shown. So now the content of the PS1 is in memory, and I can invoke the function to start the DNSCAT. The DNSCAT creator show me the function is start DNSCAT2 and the domain main. So we can execute that. For this demo, we set up a DNSCAT server, and the domain created in this occasion was DNS transfer test.site. So here we are going to write DNS transfer test.site and execute that. Okay, something could find. Okay, this part we can define the DNS server. In this occasion, we can use, for example, the Google DNS server. It's very common. And now waiting for the connection. Okay, yeah. Okay, we have now the session without problems and without alerts in the victim system. Here we have the host name, actually the same host name that we identified before. And now we have a reverse shell. For example, here I can walk through the file system. This is the directory. I'm going to create a password file, for example, here, password.txt, and it will appear in the session. So now we have total control of the victim system. We have a reverse shell and any alert in the victim system. You can see here any alert. The first part, Windows Defender sends to the operating system an alert when we saw the first detection, and AMC alerts to the operating system to any malicious code was executed. The category name was exploit, and the source name, the collector, was AMC. This is the path of the detection. We're gonna see in the Lumu portal. I'm going to log in it. And this part, analytics, let's see how in the anomalies section, the tunneling was detected. So we can see here the IP address from the victim machine. And here in some more details, we can see all the data that was transaction between the victim and the malicious server, and how the subdomains was used to transfer all the information and transfer all the session in this case. So here we can also download the entire session to try to identify the entire list of subdomains or another small things. So this is the IP from the victim.
All right, thanks, Mario. So the first question we have here is from Enrique Yanez, and the question is, which EDRs? Can you name them? I do want to say our intention here isn't to name and shame different EDR vendors. I do know there was a fascinating session at, I think it was DEF CON recently, where they talked about, they basically said that every commercial EDR is susceptible to one kind of bypass technique or another. I don't know, Mario, do you have anything to add to that?
Yeah. Every EDR provider that takes information from the AMSI collector is susceptible to be evaluated with this technique.
Okay. Have you tested it with multiple different EDRs personally?
Yeah, a lot of providers, but Windows Defender is the first because it's the base of the security environment. For example, CrowdStrike, also Sophos, a lot of providers really.
Okay, we get getting a few more questions in. I do want to ask you just a personal question. If you did this bypass technique without explaining the steps and you were just performing it yourself, how long would it take you? How much time?
Sorry, Julian, I didn't get it, the question.
Like, how fast can you do this technique?
Okay, how fast? I don't know really. I never stopped to think it, but I think maybe less than 1 minute is enough to perform the evasion. Less than seconds, maybe 10 seconds, if we can automate the process.
Okay, so we have a few more new questions coming in here. The next one is from Bart Horman, and it goes, so basically the evasion of any anti-malware, EDR, etc., is based on tampering with AMSI. Is that correct?
AMSI is just a technique. It's one of a lot of techniques, like, for example, the API hooking, process injection, memory evasion, tampering. But AMSI is a really good and very important technique because it's transversal to several providers. So every EDR provider that takes information from AMSI is susceptible to be bypassed.
We do have a report that looks at various different EDR bypass techniques, and I think we'll be sharing that with you when we send the recording to this demo in a day or two. Okay, and the next question is from Luis Hidalgo. Is any EDR safe from this technique?
I think that the EDR that is able to detect the first step, but it's very complicated because the first step in this case was performed via Gemini. I think simply say to Gemini, okay, Gemini, this is my code, please obfuscate to try bypass the AMSI. And Gemini do it. So if any EDR is able to detect the first step, the obfuscation step, maybe could avoid the attack, but this step could change very easy.
I see. Okay, we're getting quite a few more questions in. The next one is from Josue Ruano. Would this bypass work with EDR with AI or behavioral analytics like CrowdStrike or Sentinel-1?
It is in the same line, the same way the last question. Just if the EDR is able to detect the first step, the behavior of the first execution. But if the EDR can't do it, the rest of the attack is performed always.
Okay, the next one is from Roberto Latorre Diaz. Problems with EDR. So does this apply to XDR too? And how does Lumu integrate best with XDR?
Yeah, this is a good point because to me, organizations should focus on network security and user behavior anomaly. You know, the network is mandatory way for attackers to communicate with their artifacts. With the exception of insider attackers, they must be connected to insert, to inject, to control, and exfiltrate information through it. They have no other choice. A robust network security strategy, ranging from a perimeter layer to network monitoring solutions that responds at the speed. It's very important. The speed that required by today's cybersecurity environment helps our organization respond if other layers such as endpoint security measures fail. In this point, enter Lumu, because Lumu is monitoring the network 7/24, is able to detect disconnection with the malicious infrastructure.
Okay, we're getting a couple more questions just that are a bit more Lumu specific, so I'm going to focus on those. The first one is in the chat from Tom Cole, and he asks, is there a way built into your software to monitor for a persistent common reverse shell when it is established using this method?
Okay, in this case, we detected the DNS tunneling because Lumu has capabilities to detect anomalies in the network. Anomalies using AI algorithms. So in this case, detect the DNS tunneling. Lumu can detect also DGA behaviors and command and control tunnels or shells also.
Okay, and I think that ties in with the same kind of question that Andre Payne is asking. I may have missed this, but where does Lumu fit into the situation? And I think you just answered that.
Yeah, I think it's very similar to the last question.
Okay. Next, we have a question about zero trust from Bart. Would a zero trust process nullify this kind of tampering, as in PowerShell is ring-fenced?
Okay, yeah, I think this is very important. For example, for exercise to test EDRs and other ways. To me, all this exercise and tests for specific tools doesn't have sense. It doesn't make sense if you don't have a cybersecurity strategy, because you have to prepare a strategic that approach the organization from a reactive to a proactive posture. If the normal way in your network is the chaos, you can identify where are the anomalies. So for this reason, zero trust is very important. Every cybersecurity strategy is very important to develop all the anomalies in the network.
Okay, good. A couple more questions here. Another one from Andre, and it's since this is no longer a secret, what are the EDR providers doing to prevent this from happening?
I don't know, really. I think they are focused on this first step, the trying to detect for any way the obfuscation of the codes and other ways, but it's really difficult to do it.
Okay, good. We have a little bit more time left, so I'm going to continue with the questions. Let me see. How can organizations proactively test their EDR solutions to identify potential weaknesses against evasion tactics? Like, how can you test your EDR?
Okay, I said before a little bit about that. I think proactively testing for EDR solutions demands moving beyond isolated exercise. Achieving true resilience requires that testing is not just an standalone event, no, but an integral component of a holistic cybersecurity strategy. Using tools alone without a framework isn't enough, that I said before. I think the key is to create a testable environment that continuously validate the organization's security policies, and this part also enter Lumu. This strategic approach transform the organization that I said before in a reactive to a proactive posture, ensuring that this EDR can resist sophisticated evasion techniques with the help, obviously, of other layers, such NDRs, XDR, or products like Lumu, which continuously monitoring its network so that should an attacker evade the EDR, the connection to the malicious infrastructure can be detected. So anyway, when conduct this specific test with the help, for example, of BAS teams or BAS tools or red team or purple teams, organization should focus on simulating a range of modern evasion techniques. To me, this makes a lot of sense. Like living off the land, for example, using trust system tools, binaries, drivers, and all the living off the land pool. AMSI test, API hooking, and direct calls using the EDR, process injection, memory evasion, tampering with the EDR agents is very important. Attempts to disable, blind, and otherwise that interfere with the correct functionality of the EDR.
Okay, good. And the next one is, what is the worst example of EDR evasion that you've seen?
Okay. In the real life, in the wild, we discover an APT, malicious actor, on the CTI Lumu team called Copode we wrote a technical article about it. It was a variant of Logbit 2. We discovered how the attacker used in the first step of the attack the EDR folder, leveraging that security tools don't monitor it, to save the preparation files, all the code, all the scripts. So the attackers performed the discovery stage. They bypassed the real-time EDR protection, turned off the EDR itself, and all the endpoint protection. Because you know, when you install an EDR, it replaces the OS security, including the system firewall. So I believe it was the worst case that I see, because as it's not only fail or avoid the prevent intrusion, but was used to carry it. To me, it was the worst case.
Interesting. All right, I think we have time for one final question, and this question comes from Bruno Castel. The technique applied today, does that work similar for DGA detections on Lumu?
Not really. Lumu can detect the communication channel. It's more focused on the detections in the network, you know, because the EDR is susceptible to this kind of attacks. In this case, the detection of Lumu was make it sensing the network and alerting the DNS tunneling situation, more focus on the network.
Okay, that brings to a close all the questions we have for today. I would like to thank everyone for the great questions, and also thank Mario for sharing your expertise and your demo with us today. As I said earlier, we will be sharing a recording of this webinar in the next couple of days. Thank you for joining us, and we look forward to seeing you at our next webinar. Thank you, and goodbye.
Thank you. Bye-bye.